Well, good morning from Two Happy Children Farm. We're going to be doing some soil quality analysis today on the farm. As you know, we're a minimum till or no-till farm here, and we've been using our ground for 2 years. It hasn't had any tillage really go through it, except for some subsoiling to get it initially loose. And we want to just start monitoring the water infiltration rates for our no-till soils. Our soils are in the 2.5% to 3% organic matter, and one of the contributing factors to how fast water infiltrates is the percent of the soil that's organic matter. Our soil is also a high clay soil, so our cation exchange capacity is in the 30 to 40 range versus sandy soil, which might be in the 5 to 15 range for cation exchange capacity. So that would indicate the water is going to filter through slowly. What we want to know is when we do get a rain event, how much of that soil will be absorbing water, and this is a good test for that, and then how much of the soil will have the water running off. So the higher infiltration rate, the more water will actually stay in the soil, which will benefit our crop all through the season. So what you need to do this test is a 5-gallon bucket, and we've sawed off the bottom. So we have a cylinder. If you don't have a 5-gallon bucket, you can use any cylinder you like. You'll need something to measure water, so we have quart jars. You'll need plastic at the bottom. You might need a tape measure to measure the volume of your cylinder, and then you're going to use a calculator to calculate how much gallons of water will create 1 inch of rainfall. So in these tests we're going to be using 1 inch of rainfall and then measuring how long that inch takes to soak in. So as you all remember from geometry, the volume is equal to 2 pi r squared times the height. In this case we have 3.14 is pi. R squared was 6 inches, so R is equal to 6 inches on this 5-gallon cylinder, and you can get any cylinder you want, so that's 36, and height is 1 inch. So we come up, use our handy dandy calculator, and we're basically multiplying pi times 36. It's 113 cubic inches. Now this calculator has a really great feature that we can calculate units with it. You may be able to find this online as well. So we got 113 cubic inches, so I'll plug that in, and then over here we can convert it to gallons. So it's about 1/2 gallon of water to create 1 inch of rainfall. So I have 2 quart jars with me and 4 quarts in a gallon, so about 2 of those jars will create 1 inch of rainfall. So let's go out to the field and run the experiment. You also need a stopwatch, so bring a stopwatch with you. Alright, so now we're out in our no-till cornfield. This is January, I think it's the 10th, and this field was harvested August 1st or so, and since then we have done nothing to the field except come through. You can kind of see where the subsoiler went, but we've had probably 20 inches of rain since we've harvested, and the rain began in November. So these stalks have just been breaking down on their own. It was about 140 bushel crop here, but we had a good plant population, and so there's a lot of residue that was created by this crop, and that's what we're into. We're trying to build organic matter. So what we're going to do is we take our bucket and we go to a spot in the field, kind of representative of the field, clear out the rocks. It'd be nice if we could get it really level. But I take my bucket and I rotate it and get it into the ground about 1 inch or 2 so that there's no gaps. So I've rotated my bucket, got it into the ground. You'll see there's some lip here around the edge. So I just fill that in because we don't want the water to directly go out the edge of the bucket, leaving all that organic matter that's there. This is pretty interesting cross section of the field here, and we have, you know, maybe 10% organic matter covering the field still. It just shows here in Texas that you're constantly breaking down that residue. We're above 50 probably 300 days a year, so that residue for the northern farmers might be pretty intimidating, but for down here it gets really soft and broken down in a hurry because of the temperatures. You can just see the microbes have been having a field day breaking that down. So I don't think I'll have any trouble with planting here in about 6 weeks. My cultures are going to have no trouble breaking that through, pushing it aside with my openers and getting a good stand. Alright, so the bucket's ready to go. So the next thing we do is we take a sheet of plastic and put it in the bottom of the bucket, and that way we pour our water on the plastic. It doesn't instantly go into the soil and smash the soil, and then we're going to pull that sheet of plastic away with water in it. Alright, so we calculated that we needed half a gallon of water, so I got 2-quart jars. Pour that in the plastic. See, it just makes a shield so it doesn't immediately go into the ground. We're going to run this test twice. Right now the topsoil is pretty dried out, so we want to account for the true case where the soil is wet and not get a bad estimate. So we're going to run this twice. This is the second run here. And let's go turn on the stopwatch. So here's the stopwatch. We hit start and we pull out the rug, so to speak. And there's our inch of water, and we watch it go down with the stopwatch. Alright, so now it's a waiting game. Some idea for you is in a heavy soil like this, an inch an hour is about right. It can go up to 10 or 12 inches an hour depending on how much organic matter you have. Sand would probably be 8 inches an hour. So we could be waiting here a while. It's very important you push your bucket in 2 to 3 inches, and that way you don't get a false reading of just having all the water go out the side of the bucket as soon as you pour it in. And also, this is the second run of this test, so this top soil is already saturated. And here goes the stopwatch. We're at about a minute into the test, and we'll just be waiting here until we see dry soil at the bottom. Alright, so we finished our test on rainfall infiltration on the farm, and I did an experiment where I actually wanted to look at what would it be like to get a 3-inch rainfall or more than 2 inches, since that's what we're more commonly getting here compared to the nominal ½ inch at a time. So what I did is I put the bucket and I put down 1 inch of water to start with to get the soil wet. And then the soil conditions right now, we're basically, you can make a ball with your hand. We're not fully saturated, but we're making a ball in the plant root zone. So it's pretty wet, too wet to cultivate or plow. So I put that 1 inch down to get that soil fully saturated. And then I put another 1.5 inches of water in the cylinder and let that soak. So to get that full 2.5 inches of water into the soil, it took us 2 hours 45 minutes, or 2.75 hours. and that condition would be like what would it be like to get a rain right now, 2.5-inch rain. We would be seeing a 0.9 inch per hour infiltration. So when you're getting more than an inch of rainfall rate per hour, that would mean we're going to be having puddles in the soil, and if there's a lot of slope, then we'll start having runoff. The water will be running off. The other, which is what you don't want. You want to keep all that water in your soil. And then the other way to look at it is if we're getting a rainfall on a fully saturated soil, meaning it's complete mud and pudding all the way to the top of the soil, our infiltration rate is 0.545 inches per hour. So our range of infiltration rate on the soil today after 2 years of no-till is 0.545 to 0.909 inches per hour, and we're going to track this every year. Hopefully the organic matter will start bringing that number up, and we'll be looking at doing other things to increase the infiltration rate, because rain makes corn, and the more rain we can keep in the soil, the more profitable we'll perform. Hope you learned something and enjoyed this video. One way we're tracking soil health at Two Happy Children Farm. Thank you.